So today, we're diving into a really cool breakthrough from MIT that's tackling one of the biggest and honestly most expensive problems in artificial intelligence right now.
So let me ask you this. What's the single biggest thing holding us back from developing even more powerful AI? It's a simple question, right? But the answer is surprisingly complex, and it really all boils down to two things: time and money.
We're talking about a specific type of AI here, what are called reasoning LLMs. Now, these are not your everyday chatbots. Nope, these are the heavy hitters, the models designed for super complex tasks, like helping a scientist map out a new molecule or writing an entire piece of software from just an idea. But all that incredible power, it comes at a staggering cost.
And here's the paradox, the kind of crazy part. Even as these models get smarter and more capable, the way we actually train them is just incredibly inefficient. The whole process is so wasteful that it's basically creating a huge bottleneck, and that limits how fast we can innovate and build the next big thing in AI.
Okay, so where is all this time and energy actually going? Let's pop the hood for a second and zoom in on the specific technical problem that's happening deep inside the computers when these things are training.
Now get ready for this, because this number from the MIT research is just wild. A massive 85% of the training time isn't spent on what you'd think of as learning or updating the model. No, it's spent on this phase called rollout, which is basically just the AI generating potential answers. Only 15% is the actual training. That's it.
And this slide right here explains why. Imagine a whole team of computer processors, and they all get a task. Some of them get easy ones and they're done in seconds, but others get these really tough problems that take way, way longer. The problem is, the fast ones can't just move on to the next thing. They have to literally sit there, idle, just twiddling their thumbs, waiting for the very slowest processor to finally catch up. It's a total waiting game.
So this led the MIT researchers to ask a brilliant question. What if all that wasted idle time wasn't wasted at all? What if you could actually put those bored, waiting processors to work and turn that massive inefficiency into a huge advantage? And that is exactly what they did. They called their solution Taming the Long Tail, or TLT for short. It's this new, really smart, adaptive system that's designed to hunt down that idle computing time and use it to speed up the entire training process, all without adding a single penny to the cost.
As the co-lead author, Qing-Ha Hu, puts it, the goal was simple but incredibly powerful. Turn waste into speed. I mean, this quote just gets right to the heart of their elegant solution.
Okay, so how does it actually work? Well, the best way to think about it is like hiring a clever and incredibly fast assistant for your main AI model.
You basically have two key players. On one side, you've got the main AI model. Let's call it the manager. It's unbelievably smart, super accurate, but it's a little slow. Then on the other side, TLT introduces a new, smaller model called the drafter, our smart assistant. This one is lightning fast at coming up with ideas, but, its work probably needs to be double-checked by the manager. So here's how the team works. First, the speedy drafter model just churns out a whole bunch of potential answers. Think of them as rough drafts. Then the powerful main model, the manager, just looks over all of those drafts and verifies them in one single go, which is way faster than thinking up every single part of the answer step by step on its own. The result? A massive speed boost.
But here's the real magic, the absolute key innovation here. That drafter model isn't just set up once and left alone. No way. It is constantly being trained and updated on the fly, using those exact same processors that would have otherwise been sitting around doing nothing. This keeps the assistant perfectly in sync with its manager at all times.
And this quote from the author really drives that point home. The absolute second a processor has free time, boom, it's immediately put to work training that assistant. It's just an incredibly dynamic and efficient use of resources.
Okay, the theory sounds fantastic, right? But does it actually work in practice? Let's get to the results and see what the real-world impact of this taming the long tail method really is.
So here's the headline number. On average, the TLT method makes the entire training process twice as fast, a 2x speedup. That is a dramatic, almost unbelievable improvement in a field where every single percentage point of efficiency really counts. And you can see it right here, plain as day. The time it takes to train these gigantic models is essentially cut in half. And remember, this is all achieved with no extra hardware and no extra cost. They're just using the computing power that was already there, but was being completely wasted.
And maybe the most important part of this whole thing is that this speed up comes with zero trade-offs.
The researchers call it a lossless solution for a reason. The final AI model is just as accurate and just as powerful as one trained the old, slow way. You get all of the speed without sacrificing any of the quality. So a 2x speedup is a huge technical achievement for sure. But what does it really mean for the future of artificial intelligence? Why does this actually matter to all of us?
Well, the implications are just enormous. Cheaper development means more people and more groups can actually afford to build these powerful models, not just a handful of giant companies. It's more energy efficient, which, let's be honest, is a huge deal for sustainability. And in the end, it just means a faster pace of discovery, which speeds up breakthroughs, not just in AI, but in every single field that uses it, from medicine to climate science.
As senior author Professor Song Han said, this work directly attacks that critical computation bottleneck. It's a fundamental step forward for the entire field of efficient AI.
Which leaves us with one final and pretty fascinating question to ponder. If we can now train AI twice as fast for the same cost, what new frontiers is that going to unlock? What becomes possible tomorrow that just wasn't possible yesterday?